Good afternoon, good morning, everyone. Welcome to this very special webinar brought to you by CARTO. My name is Helen McKenzie, and I will be your host today. Today's session is all about visualizing massive data and turning enormous, really noisy data sets into stories that are compelling to your end users and can help them make decisions. This session is going to be about 45 minutes to an hour long. There is a chat and a Q&A, so if you do have any questions at all, feel free to drop them in the chat, and hopefully we'll have a little bit of time at the end to go over them. And if you have any problems at all, like you can't see me or can't hear me, or the slides aren't changing or anything like that, please just drop a message in the chat. Our wonderful moderator Jocelyn is there and should be able to help you with anything you need. So let's get started. So, first of all, just to introduce myself, I've seen quite a few familiar names on the sign-up sheet, so great to see so many old friends here today. For those of you who don't know me, my name is Helen McKenzie. I've been working in geospatial and data viz and cartography now since about 2012, which is feeling like a very long time. And my job here at CARTO is what we call a Geospatial Advocate. So it's my job to hopefully get people really excited about the world of geospatial and really see its possibilities and its value, but also hopefully see it as something super interesting and super easy for them to be able to do. So today, here's what you've got in store in the next sort of 45 minutes or so. First of all, we're just going to do a bit of an introduction and talk about data visualization in general and sort of why we're talking about this, why we're doing a webinar about this topic and why it's such an important topic. Then we're going to go through what my 5 top tips are for telling stories with massive data and how you should sort of approach data storytelling when you're working with massive data and when you're working with it in an interactive way, how you should sort of approach that differently to perhaps maybe more traditional sort of GIS static outputs with smaller data. And then finally, in the last sort of half hour or so, we'll get to the really fun part, which is we're going to put this into practice and we're going to walk through a live example, which I'm sure will be full of me making mistakes and doing loads of typos and all of the fun stuff that comes with live demos. So first of all, let's get started and talk a little about why data visualization is so important. So for me, I just wanted to start off by setting the scene and setting data visualization in context. I think a lot of people think of data visualization as kind of like the fluffy end product of working with data. Maybe you create a map, you create a chart. Quite often people think, oh, just choose a color scheme, choose a font and be done with it. But it's actually, I think, a really crucial part of what is how we use data for decision making. If you think about sort of the wider process that we use data to make decisions with, typically you start off by sourcing and cleaning your data. Anyone who works with data will have probably seen loads and loads of different memes about how there's a statistic that is 60 to 80% of most of our time is actually spent on just this stage 1 of sourcing and cleaning data. So that's a huge amount of time. That means only about 40 to 20% of our time is left to do all these other 4 things. So the second part of which is data enrichment, so bringing data together from lots of different sources and different geographies. The third stage of which is actually doing the analysis, so doing the sort of problem solving, the sort of answering the question that you're trying to solve. And then fourthly, we have data visualization. So this is where you have sort of solved your problem, but you need to turn that answer, that solution into something that your decision makers can actually use, which takes us to stage 5, the actual decision making with data. So data visualization is like the last thing that happens before someone makes a decision. And it's really, really crucial because if you get that final stage wrong, that stage 4 wrong, it kind of negates everything else that you've done. So data visualization is super important and it's so much more than just saying, what color scheme should I use? So we've been digging into this a little bit here at CARTO, and some of you may be aware of or even participated in a massive survey we did earlier this year called the State of Spatial Data Science Survey 2024, which I actually had the pleasure of managing. And one of the questions that we asked people was, what is the most difficult part of working with spatial data? And hopefully my floating head isn't hiding this, but hopefully you can see that the majority of people, a small majority, but still a majority of people, 28% of people, said that the most difficult part of working with spatial data is visualizing it. And actually we run this survey every year, and this is quite common across years. This is what we tend to see pretty much every year, is this is the part that people are struggling with working with data. So actually, before I move on, I just wanted to give a bit of a plug for this report. So the State of Spatial Data Science came out, I believe, about 6 weeks ago, and it's packed full of insights from this survey, which was of about 250 people across the industry on things like AI, recruitment, talent, interoperability, loads of different things. So if you're interested in learning about any of that, please do head to our website and you can download a copy of that. There's some great stuff in there. But just to move back away from the sidebar that I went to there, I've been thinking a lot about why visualizing data is so difficult. Why are people saying it's something that is so difficult? And this is kind of what I've come up with, that what the issues are. First of all, I think it's a question of priority. I think it's that generally as an industry, we tend to deprioritize data visualization. I think there's a lot of different reasons for that. Maybe a lot of us come from a very analytical, maybe scientific background, and we're much more into the sort of nitty-gritty of the analysis, and we don't actually give as much priority to data visualization. I think it's also maybe about the way we're all sort of taught, and also the way we sort of allocate budgets. But I think generally it's just sort of given a deprioritize. It's just kind of a little bit of fluff that you add at the end. Secondly, I want to talk a bit about subjectivity. So I think one of the reasons data visualization can be so hard is because it's not as clear cut as doing some analysis. With analysis, there's obviously subjectivity and a lot of sort of user bias in there, but generally you can prove something is right or wrong. You can come up with a number, you can come up with an answer. But with data visualization, everyone has different requirements, everyone has different tastes, and it can really be hard to feel like you're getting something right, because there is really no such thing as right. Thirdly, and actually I'll go and wrap these two up together. So thirdly and fourthly, I think technical constraints and data size and complexity really make this difficult and challenging as well. I think quite a lot of, if you think about a lot of the solutions that you use day to day, a lot of them might be great for doing sort of spatial analysis, but actually really difficult to create really stunning or very customized visualizations, or kind of the opposite. They can be really great for creating those visualizations, but they don't have that analytical capability. So you kind of have to learn two different packages. So there's quite often quite technical constraints there. And then fourthly, data size and complexity, which is basically the bigger the data, the harder it is to visualize. And that's kind of the whole purpose of this webinar. So why is it that bigger data is that much more difficult to visualize? What's sort of going on there? So I think firstly, everything takes that much longer when you're visualizing big data. Like generally you have to wait longer for the visualization to render. So you make maybe a design choice and you have to wait a few minutes to see what the results of that design choice are, and then you don't like it, so you have to go through it again. And everything just takes that much longer to do. So it's really difficult to get that much closer to sort of perfection, if that exists. Secondly, something I am mega guilty of is I think the next point is sort of wrapped up in this. I think as a data lover, I'm always so tempted to just put so much data on the map because I love to see as much data as possible. And I think big data in general can actually look really beautiful. I mean, there's so many great examples of maps and dashboards that are absolutely stunning to look at. But actually, sometimes the more data that you put on a map or a dashboard or a graph or whatever it is, the harder it is to actually interpret. And I think there's often a sort of misunderstanding that a really great map or dashboard has to be super beautiful, when really, ideally, it has to be functional. It has to be something that someone can get an answer from. If it can be beautiful as well, that's fantastic, but it doesn't always have to be. That's not the main requirement. And then fourthly, obviously, with the more data that you have on a map, the more complexity that you have on a map or dashboard, the harder it is to get a compelling story out of it. And if you think about what your user requirements are for a lot of the analysis that you do, quite often the user requirements might be quite small. They might be, where should I build a cell tower? Or which road is most at risk from flooding? Or something like that. And often the answers there aren't super big or complicated. They're actually quite small, and the output of your analysis is something that's actually quite small. So as we're sort of moving forward, I'm going to be talking a lot more about sort of best practice in data visualization and how you can approach telling stories with big data. I wanted to start off with this premise, which I've used in quite a lot of, if you've ever been to any of our spatial data science boot camps, I quite often show this slide when I'm talking about data visualization, because I just think it applies so well to data visualization, which is that you don't notice good design. Obviously, if you see a map that is absolutely stunning, you're going to notice that. But generally, you don't notice really good design. You notice bad design. You notice when a map or dashboard is designed badly and you can't get to the answer that you want. But generally, you don't notice when something is designed really well and seamlessly. So moving forward through all of this, I have a golden rule for the rest of this webinar, which is user need is everything. Everything that you do, every design choice that you make when you're creating a visualization or a dashboard or a map, everything should come down to what will my user get out of this? This is obviously complicated if you have many users with many different requirements, but one of the great things about the sort of changing world of technology at the moment is there's some great ways around that. So user need is everything. So next step in this webinar, how are we doing for time? Perfect. Is we're going to talk a little bit about, I've got 5 key tips for how to tell stories effectively with massive data. So tip 1, and this is something that hopefully you're going to see threaded through the rest of this webinar, is you should be designing an experience, not a map. And what I mean when I say that is, particularly if you're working with interactive maps and dashboards, you're moving away from sort of static paper maps, you're now designing an experience, you're now designing something that people move through and they have a user journey and they don't just sort of pick up a piece of paper, look at it, and that's it. They move through it, they interact with it, and you need to design in that way and not design as if you're just creating something static. So let's think a little bit about what that user journey is, what a user does when they open a dashboard or a map. I've distilled it down into what I think are 5 main steps. That was a dramatic pause for me to have a sip of coffee. So the first step is orientation. So this is where when you open the dashboard or visualization that your analyst has crafted for you, you sort of, first thing is like, oh, where am I? What is this? And you take a few moments to work out what it is that you've been given and what it is that you're actually looking at. Then you start to explore that visualization. You start to work out, okay, like maybe I'll open the legend, maybe I'll play with a couple of the different elements and just try and get myself orientated and start to explore what it is that I'm looking at. And then thirdly, hopefully you'll come up with an insight. So as you're exploring, you'll start to drill down through the different widgets and elements and map layers and start to basically come up with what your answer is. Because generally, the reason that you've opened this dashboard or this map is you have a question that you need to solve. And that's the whole point. So your user is basically trying to get to that answer as quickly as they can. And then fourthly, something that I think is very often overlooked when people are designing data visualizations is validation. So like how many times have you created a map or a dashboard and you've said proudly sort of presented it to someone and said, here's the answer, here is the results of my analysis, and they sort of say, why? Or they say, oh, I don't really believe that. So they're often looking for validation that means that they can trust the results of your analysis. And then finally, hopefully, decision. So they will work out their insight, they'll work out sort of the answer to their question, they'll validate it, and then they'll make a decision with it. So your goal as a data visualization designer is basically to help your user get from stage 1 to stage 5 as quickly and as easily as possible. So let's look at that in practice. Let's have a look at how that might sort of work with a quick demo. I'm just gonna open this one up. So hopefully you can see my screen here. It's moved. Please, Jocelyn, the moderator, give me a shout out if you haven't seen that this has changed. You should be looking now at a map of California. So the first thing you do when you open this map, exactly what I just did there, I start to click on just generally various things and start to orientate myself as what it is I'm looking at. This map is actually quite well designed, if I say so myself, because we've got a really striking border of California here. So we can immediately see, right, I'm just looking at this area. This is what I'm looking at, map of California, and maybe I'll open the legend. Oh, I'm looking at airports with passenger numbers and these drive time areas. So that's my sort of orientation done. I know what it is I'm looking at. Then I'm going to start to explore. Maybe I'll sort of zoom in, have a look at Los Angeles. I might sort of start to click on and explore these widgets a little bit. Maybe I'll head into parameters and see, oh, I can change the drive time areas. So start to just sort of play around with that. We know people love to do that when they get into a map, to start playing with everything. And then they're like, right, I understand what this map's about. I understand what it's telling me. Now it's time to find my answer. So my question might be, which airport should I start flying my airline to? And that might be based on, well, I'm a luxury airline, so I'm looking for where people have the most income. So we can see here in this map, we can just filter our airports to that with the highest median income, which is the San Jose airport, which we can see is down here in San Francisco. And then that might be the answer to their question. They're like, okay, well, that's the airport with where people are in the area have the highest income. So they're the people I'd like to target. So maybe I'll target there. But finally, they'd probably want to do a bit of validation on that. So they'd probably initially think, well, I know that San Francisco is a fairly wealthy area, so that kind of checks out. Maybe they'd zoom in and just sort of do some sense checking on whether they think this drive time area is realistic. Maybe they would draw a line here just to sort of measure that that seems like about right, because we all know that our end users don't always trust us as analysts. And then they could say, yeah, that seems about right. Fantastic. We'll go with San Jose to stock my product. So that's kind of how I sort of picture the user journey in when someone's using a data visualization. Obviously, every user journey will be slightly different. So that's the sort of user journey, and that's something you need to think about when you're designing every element of your map. Secondly, be ruthless with your data. So when I say this, I mean that there is so often we're now working with data sets that are like petabytes and have like billions and billions of rows on them. And we need to be seriously thinking, maybe we need all of that data for our analysis, but do we need all of it on our visualization? Does our end user really need to wade through all of that data when they're making their decision? So here's some examples of how that can be something that can be quite dangerous when you add so much data to your map. So if we look at this one in the center, in the middle here, this is the UK, my home country. And what I believe we're looking at here is every sort of distribution center in the UK, and they've been sized by a particular variable. You can see they have pie charts by a particular variable. And there's just so much information on this map that is absolutely overwhelming for someone to be able to derive any insights from it at all. And maybe the better solution would have been, right, just show the top 10 things, the top 10 distribution centers on the map, or something like that. Similarly, this one on the top right here, which is showing sales of something across the USA, it's actually really difficult to interpret because it's really stopping people at that first barrier, that orientation barrier, because they can't see any of the base map. So you could kind of work out where the coastlines are, but you can't orientate yourself any further than that. So being ruthless with your data is really important. Thirdly, I think it's a good time to talk a bit about optimizing the performance of your visualizations in terms of the data that you choose. And by that, I don't mean which data you select to be on a map, but how you format your data. I think the sort of world we're living in now, there's so many new opportunities for structuring your data in a different way and thinking about your data in a different way. And rather than just always using it in its raw format, maybe as a geometry, maybe as a shapefile, whatever it is, might not always be the optimal way to work with data, particularly at scale. So I've just got a few examples of some of what I think are the coolest sort of new data sources and advances in data formats that can be really helpful if you're trying to scale your analysis. So first of all, this is a CARTO specific one. You're going to see this in action in a second. It's an absolute game changer. If you aren't familiar with what map tiles are in general, they're basically a way of breaking up your data into pre-rendered, basically images and like chunks of images. So think of things like WMS files or WMTS files. And so they become flattened images, which is great for rendering data at scale. but it means that you have to pre-generate those tiles yourself. You have to create those tiles. And it also means that any of the data on the back end of those tiles, whenever that changes, whenever you rerun the analysis or the data updates, those map tiles need to be regenerated. So at CARTO, our sort of workaround for that is our team have been working really hard on something called dynamic tiles, which basically does all of that for you. It does all of that on the fly without you having to pre-generate anything, and it just does it on the fly automatically for real-time data queries, which means that whenever your data is updated, whenever there's new data, whenever you rerun your analysis, that's reflected on the map. The easiest way for me to explain how awesome this is just to show you. So stick with me for 10 minutes and you're going to see this in action with about 11 million features. It's really incredible. Next, I just want to briefly talk about this awesome data format, GeoParquet or GeoParquet, depending on how badly you pronounce it like I do. So this is basically a really efficient way of storing your spatial data. It's a compressed and columnar format. And what this means is you can basically access data much more quickly. Your storage requirements are massively reduced, and you can just have really, really fantastic performance when you're processing big data. Something we're working on behind the scenes at CARTO at the moment is something we're calling, I'm going to butcher the pronunciation again, either Rasket or Rask. Someone will tell me off for pronouncing it wrong no matter which way I say it. But this is basically the raster version of it. So GeoParquet is very much focused on vector data. And it's been, for a long time, it's been difficult to get raster data into the cloud, partly because of its size. And that's why Rask is something that's going to be really, really revolutionary to raster data. This one is a really fun one. This is one of my favorite data formats. So aggregation tiles, it's so much easier to just show you than explain it. This is basically a way of rendering your data so that as you zoom in and out of your map, the data aggregates. So for example, here, what we are looking at is, if you're interested, public toilets around the world. And here we are in my hometown of London, and each point you're looking at here is the location of a public toilet. As we start to zoom out of the map, you'll see in a second, once we get to a certain zoom level, the points will start to fall into a grid shape here, as you can see here. And as we zoom out, those grids sort of become a coarser and coarser resolution, and the data becomes aggregated. And you can see we're now looking at what is essentially a aggregated count of the number of public toilets, which we're looking at here for the whole world. So if you have a massive point data set with a really huge coverage like this, and if I were to just show all of the points on this map, I wouldn't really be able to tell much from it. So point aggregation data sets are a really great way of telling a story with that kind of data in a really sort of easy lift. So back to the presentation. Aggregation tiles, what are next? Spatial indexes. So if you have been to a CARTO event or CARTO webinar or used CARTO at all, you've probably heard us banging on about spatial indexes because they are absolutely revolutionary. So spatial indexes are referred to as a lot of different things in the sort of data world. What we mean here is discrete global grid systems, so things like H3 and Quadbin, if you've heard of those. And these are basically multi-resolution grid systems that are hierarchical, so the different resolutions fit into each other. And people generally use them as support geographies, so taking data from lots of disparate sources and aggregating them to this common grid, which has a bunch of benefits, but the main benefit is this. So if you remember a couple of minutes ago, I was talking about how it's important to think a bit differently about the way we deal with geometry data. Now we're working with it at a much bigger scale. Well, conventionally, we think about geometry data a bit like this, right? We have a bunch of what here are coordinate pairs that represent a vertex of a shape. And with a geometry data like this, your GIS software or whatever you're using knows to basically join the dots between all of those coordinate pairs. Now, this represents the geometry of a census tract, which is a sort of mid-size administrative geography in the US. And this actually represents only about 1/10 of the size of that census tract. So imagine this times 10, and that's the amount of information that you need to visualize one census tract. And now imagine that times, I actually don't know how many census tracts are in the USA. So if you do know, please put it in the chat. It's probably, I think it's a few thousand, might be a few tens of thousands. But basically that's a huge amount of data, right? That means it's it's kind of expensive to store, very slow to analyze, and really difficult to render and visualize. The difference with spatial indexes, as you can see here, is they encode location, not with this long geometry, but with this short string that you can see here. So you can see here, that's about 14 characters. And that tells a platform like CARTO what size the cell is, what shape it is. Is it like a hexagon? Is it a square? Whatever. Where it is in the world, what size it is, what its neighboring cells are, what its parent cells are. So remember I said they're hierarchical. And that's a huge amount of information to contain in just a short string. And you can see that the size difference here is really clear to see. It's basically you can store, these are absolutely tiny to store, and they're really fast to analyze. I'm still sometimes shocked at how quickly I can run analysis with spatial indexes, but they also enable really sort of slippy, seamless visualizations that look absolutely incredible because they're so small. And we're going to be working with them in just a second. And in fact, I'm going to show you one right this second. If I can remember which of my tabs it is. This one here. So this is a spatial index. It covers the entire of the USA, and it's basically showing human mobility data. And if we zoom in really far here, we are in Florida, and we're looking along this road connecting Miami and this city over here. And what these points are here that you can see, these sort of tall towering blocks, these are basically gas stations. These are basically, we can pick out individual gas stations using this map. But we can also look at things on a much bigger scale. So I'm going to start to zoom out, and you can really start to see how seamless and how slippy these visualizations are using spatial indexes. What you can also probably see is as I zoom out and zoom in, the resolution that the data is being mapped at is changing. So the resolution, it becomes coarser as I zoom out and more sort of fine and smaller resolution as I zoom in, making it much easier for the human eye to basically understand. And it's also aggregating this data on the fly as I zoom in and out as well. So you'll see the colors sort of shifting, and you'll see the heights of the 3D data shifting as the data is aggregating, as it moves between those zoom levels. And now here you can see we're looking at the whole of the contiguous USA. So this is an absolutely immense amount of data. I think this is something like 200 million points or 200 million cells. But you can see how sort of slippy and seamless it was to visualize that. And that's all because of spatial indexes. So thinking that bit differently about the way you visualize data is really important for enabling things like this. You can tell I did this presentation by myself because I'm not normally supposed to put in animations like that. If you're interested in learning more about spatial indexes, we have an ebook all about spatial indexes called Spatial Indexes 101. It's basically a handbook. It's got loads of practical tips and tutorials for using them. I would recommend that you wait to download it for 8 days because we have a new edition coming out next Thursday, which is all about spatial indexes, the sort of low code edition. So you won't need to know any SQL to be able to use that new version. Fourthly, I'm just trying to jump through these so we can get to the fun part and get to the mapping. It's really important to optimize your performance and actually consider what tools and platforms you're using to help you work at a bigger scale. I'm gonna do a slight CARTO plug now, but do bear with me because it really is, this is our whole MO, like big data is what we're all about. So the reason CARTO is so powerful for helping you work with big data is that we are a fully cloud native platform. So we work on top of all of the leading cloud data platforms, and CARTO is actually fully installed inside that your cloud platform and inside your data warehouse. So none of your data ever has to leave that data warehouse. It's not even cached anywhere else. It stays completely inside the data warehouse. So that guarantees you incredible speed, incredible scalability, but also really guarantees you security because you know that your data is safe in that one location. So this is kind of a little visualization I put together of what the difference is between using something like CARTO with its cloud native approach and using a sort of more conventional desktop GIS. You can see that with CARTO, and this is a function of those dynamic tiles I was mentioning earlier as well. So this is looking at the exact same data set. And you can see with CARTO, you can sort of pan and zoom around really quickly and really easily. Everything's rendering really easily on the fly. And you can see with the desktop GIS, it's just that bit trickier because you're having to wait for the data to re-render every time the map extent is changed. And if we think back to the start of the session when I was saying how part of the reason data visualization for massive data is so tricky is because you have to sort of wait to see the results of it for it to render. This is exactly what I mean. So I'll just move on. Finally, on this little section, I just wanted to mention briefly business intelligence tools like Tableau and Power BI, which are really fantastic tools when you're working with smaller data. The reason for that being is that all of the analysis is happening in memory. But as your data sets start to get larger and you start looking at tens of thousands, hundreds of thousands of data points and rows, in-memory processing really starts to struggle and you start to have lots of performance issues. So if you are working with those sort of much, much bigger data sets, then particularly if they're complex geometries, like that census tract we were looking at earlier, you might want to consider another approach that's more focused on spatial platforms. If you are using a business intelligence platform and you're sort of feeling like you're having performance issues, my colleague Matt did a webinar a couple of weeks ago that's all sort of about that and all how you can overcome some of those challenges. So I recommend giving that a listen. And then finally, before we move on to the fun stuff, is interaction is key. So I think we don't live in a world where all visualizations are interactive now. There's obviously still a huge demand for static maps and paper maps and things like that. But interactive maps really have been a huge game changer in so many ways for making data visualizations so much more powerful. So first of all, they're really key to facilitating a broad user base. If you remember at the start of this, I said that user needs need to be absolutely key to everything that you're doing. The problem is when you have very diverse users with very different needs, and interactivity is your best friend for helping you overcome those issues of trying to please all of your different users because they can sort of do what we call self-serve analytics with your visualization. This is also great for you as well because it saves you time. You don't have to create 10 versions of pretty much the same map because people have different needs. They can basically create those versions themselves. And in that way, it reduces you edit time because you also don't have to be constantly tweaking a map to people's requirements. We've all sort of, I quite often say back when I used to work in GIS consultancy, I probably spend about 50% of my time doing my initial analysis and visualization, and then about 50% of my time making sort of tweaks and edits that my managers would want. So this can be really helpful there. And I wish I'd been doing that work when there was a lot more interactivity available. And fourthly, and really importantly, is bringing users closer to the data. So I've mentioned this a few times, but I think as data analysts and data scientists or whatever job title you have, basically data professionals, it's our job to make sure that the people we're running analysis for and creating visualizations for feel like they can trust us and trust the work that we're doing, but also trust the data and basically trust the integrity of the answers that we're giving them. And by bringing them closer to the data and allowing them to play with the data in a way and sort of get under the hood of it and see what's there and sort of validate, like I was saying, validate it earlier, it just builds a lot more trust and transparency. So they really feel like they can trust the answers that they're getting. Now it's time for the mandatory AI mention. I've lasted about half an hour, so I think we should all be really pleased that we've gone that long without mentioning AI. But something that is coming to CARTO that we're really excited about is CARTO AI agents. So this is basically, as you can see here, almost like an assistant that you can add to your map for your end users to basically help them do things like interpret the map, ask questions about the data, run some filters, help them control dashboard elements, and basically give them that level of interactivity, even if they don't necessarily maybe feel confident interacting with the map interface themselves. So that's something that is coming later this year, and we're super excited for it. So that is my sort of 5 top tips for crafting compelling data visualizations with massive data. Now it's time to give that a go. So I've mentioned a few times today that I see data visualization and data analysis as basically solving problems with spatial data. So let's do that. So let's say that we work for a anonymous private hire vehicle in New York City, and we're having a big problem in our business. We're going to imagine that our vehicle insurance prices are absolutely skyrocketing at the moment, partly because of the amount of accidents and collisions that are happening across New York, is just meaning it's really difficult. It's basically eating away at our profits. So what we want to try and look at is to work out whereabouts in our business are our trips basically going through areas of starting and ending in areas of high risk. Are there a significant number of trips that are at high risk? And just working out if we can build that into our pricing strategy at all. So to do that, we know two things. We have two things that we can use. We know where the collisions have occurred, and we have 1.9 million collisions to look at. And we know where all our trips start and end. So we have 11.2 million trips, which is 22.4 million points. So we have those two things, and we can use them to solve this problem. So let's get started. I'm going to come out of here, and I am going to not accidentally leave this webinar. I'm going to head to the CARTO workspace. I'm just going to make this full screen so it's a bit easier to see. Hopefully you can see that and it's all nice and clear. So if you aren't a CARTO user, this is basically what CARTO is. And if you aren't a CARTO user, we do offer a 14-day free trial, and everything that I'm showing you today is available in the free trial. It's all data that you can use. It's our demo data, so anyone can access it. So this is what the CARTO workspace looks like. And the first thing we're going to do, let's take a look at some of the data that we're going to be working with. So I'm going to head here to the Data Explorer, which is kind of like the File Explorer, and I'm going to find our trip data. Let's head into the data is saved here in the CARTO data warehouse, which is basically where we save all of our demo data. So you can access all of this yourself. If you're a CARTO user, why not pull up the screen now and take a look yourself? Let's just zoom out a little bit here. So this is what we're going to be using for the bulk of our analysis. We have our New York City taxi rides, and you can see here, hopefully it's a little small, sorry. We have 11.3 million rows, that's 2 gig of data. If we preview the data, we can see we have our pick up and drop off geometries and all sorts of interesting information like day of week, part of day, etc. I'm just gonna go ahead and, oh, my Skype window is hiding everything useful for me, thank you. I'm just going to go ahead here and hit create map so we can take a look at this data. So this is CARTO Builder, which is basically the mapping platform. And you can see, I was talking about dynamic tiles earlier. You can see how quickly this loaded, 11.2 million points, it's amazing. But obviously, like, just take a look at this data. How is our end user supposed to make heads or tails of this data in its raw form? They aren't. This is just way too much information. There's a couple of tips and tricks you can use to sort of when you're working with data of this scale. So something I quite often like to do, for example, is turn on a Dart base map and use the additive blending mode, which is what we often refer to as Firefly cartography. And this sort of helps you see the shape of the data. But even still, it's kind of difficult to make heads or tails of this. What we can also do, if we go into our layer panel, we have our visualization options here. So we can do things like change the visualization to be a heat map, like so, or we can choose it to be visualized by an aggregation grid like H3, which I've mentioned a couple of times. And that's exactly what we're going to be using as our support geography to help us tell a story with this data. So I'm going to head out of here, and we will start to do some analysis and start to turn this into a bit of a story. So let's just head into CARTO workflows. So if you haven't used CARTO before, another part of our platform, which is really, really fantastic actually, is CARTO Workflows, which is basically a low-code drag and drop interface for running multi-step analysis. Sorry, I hope you can't see this. I'm having to keep moving my face away from the important parts of the screen. And this is what CARTO Workflows looks like. And this is on a normal webinar, I would go through this and build this, and we would all run this together. But this is all about visualization, not analysis. So I don't want to spend too much time on this. I'm just going to quickly talk you through what I've done here, and then we'll turn the results of this analysis into a map. So first of all, we have our New York City taxi rides that we were both looking at, that we were looking at earlier. You can see we have our 11.3, sorry, million rows in here. And what I've just done is I've converted all of those taxi rides, the pick up and drop off points, to a H3 grid here. So if I just open this preview, hopefully you can all see, here we have our ID column now called H3. And this is, like I was showing you in the slides earlier, through this short ID string, CARTO knows what shape this grid cell is, where it needs to be in the world, what size it is. We have everything we need to know in this grid. So that's our first step. We've converted our taxi ride pickup and drop off locations to a grid. These components here are basically all just doing a bit of data cleanup, renaming columns, etc. So we can just move past those. The next sort of key part I want to draw your attention to here is this section where I've basically joined, I've given each H3 cell a neighborhood name. So we have here this input source, which again is in the CARTO demo data if you'd like to use it. We have here basically all of the New York City neighborhoods. And what's really helpful when you're creating a map is adding contextual information to your data. So rather than just sort of putting it on a map and having people try and figure out where things are from the base map, by adding contextual information like neighborhoods or which borough they're in or things like that can really help people navigate the map later on. So when you're running your analysis, it's always good to be thinking, what will the end result be and how can I help my user orientate themselves and explore the map and validate the results as well. So that's the next thing we do is we end up here. If I just preview this component, we now have our H3 cells, and right at the end, we have NTA name joined. The reason these are null is these are in the ocean. The first ones are always in the ocean. And then finally, something else I've done here is I've already, in another workflow, run hotspots on my collision data. So this is basically working out where there are statistically significant clusters of a high number of collisions, essentially. So then what I have done when I've joined all of that together, I appreciate I'm going through this super quickly. I just want to get to the mapping stage. But basically, the main thing to take away from this workflow is we've now created this table that has everything we need to know in it. We have our H3 cell, so we can plot this table on a map. We have all of this sort of background information about when all of the trips were, which we'll be using in our visualization to help our user sort of drill down to the data that's relevant to them specifically. Then we have whether the row is a pickup or a drop off. We have the neighborhood name. Again, this is saying null, but I promise you there's data in there. And then we have our hotspot label. So this is telling us whether each cell is an accident hotspot or not. So that's all the information that we need to be able to basically tell our story to our end users, which is exactly what we're going to do. So I'm just going to open up this panel, go into the map preview, and hit create map. And we're going to head back to CARTO Builder, but this time we're going to turn this into something a little bit more engaging. So you can see that our layers are being created in CARTO Builder, and with that we have this SQL editor at the bottom, which we're going to be coming back to a little bit later, but this is where we can basically start to refine our visualization. So let's just close that. And the first thing I'm going to do, because otherwise I'll be told off, is I'm going to name this something sensible. So let's call this New York City taxi trips. And we will rename the layer as well. Taxi pickups and drop off. This is where I start to do lots of typos and embarrass myself. And the first thing I'm going to do when I'm looking at this is I can't really see anything. I can see the grid, but I can't see any contextual information to help me start to draw out maps. So I'm going to change the base map and I'm going to change it to Google Maps Dark Matter. The reason I'm doing that is because the Google Maps base maps have labels which sit on top of the data rather than beneath it. So if you're working with a polygon or basically an area data set like this, it's really helpful to have the labels on top of the layer. If you're working with a point layer, often you want the labels beneath because otherwise they sort of block the data. And the reason I've chosen a dark base map is it's my favorite and my colleagues say I'm addicted to it. And they're definitely right. So I'm also going to switch this, the blending mode, which is basically the way that layers interact with the colors on the base map. I'm going to switch this to additive. And this just means that we can see, as I zoom in, you can see that we can see the base map much more easily. And then I'm just going to go into the layer styles and turn off the stroke, just it's really noisy and it's hurting my eyes. So now, and also what I'm going to do is I'm just going to change this aggregation size. So when we're working with spatial indexes, we can change the size that the cells are visualized on the map. So let me just zoom out and show you what I mean. We can show the data at its most coarse, like so, which for this use case is absolutely inappropriate. We want to be showing this quite detailed. So let's just change that to a level 5, which is that little bit more detailed. And then what we need to do here is at the moment, we're basically just looking at the area of our data, but we want to see a little bit more information here. So I'm just going to go back into that SQL console that we saw earlier. And what we're going to do is we're going to turn this layer from having every single cell on the map. We're going to group them together. We're going to aggregate them. So I'm just going to write out a bit of SQL here. Now, a lot of what I'm doing that you can see with the SQL, if you're not a coder or if you prefer not to code, you can actually do this all in CARTO workflows. But I want to do something kind of funky with something called SQL parameters in a little bit. So I do need to be able to doing a little bit of SQL here. So all I need to do here is I want to group all the cells by H3. And then we want to show the H3 ID, and then we want to know, oh, more typos straight away. So what we're doing here is we basically are grouping every cell here by the H3 ID, and then we're counting the number of cells a group. So this is basically going to give us an aggregated grid of the number of origin and destinations within each cell. So that's run. And now we should have, if we go down to fill, you can see we now have this H3 count variable that we can use to visualize our data. So let's just set that. And let's expand the layer options. Great. So you can see we've already got visualization there. I'm just going to switch that color scheme around so we have the lower values are represented by dark colors, which are more in keeping with the map. And then I'm just going to, you can see here, we can set the different data classification methods. I'm actually just gonna, so for example, you can say quantize or quantile. I'm actually gonna set this as custom for now, because there's something I want to show you later with SQL parameters again. All roads lead to SQL parameters. So let's just set this. So great. So here we are now. Great. We can see the number of origins and destinations for our taxi trips that have happened in each H3 cell. But that's only kind of half of our problem, right? We wanted to know where do we have trips starting and ending, but where are they intersecting with hotspots? So let's go back to our SQL query. And what we just need to know is you can see we've only got these two variables here. We need to make sure we just also take from the original data our hotspot labels. So if you remember, let's just exit full screen. If we head back to the workflows, you can see here in our data set, we have this field here, hotspot label. So we want to make sure we bring that through again. So back to our map, and we'll just add that in here. Great. So we'll just quickly rerun that again. And I think it's also important to think like this kind of stuff's taking 3 seconds, but we're doing this on over 11 million rows. So now if I go into interactions and we just add a pop-up and we bring through a couple of our fields into here, then we can see, oh, wrong one. we can see for each of our cells, once this is initialized. So here we can click on each of our cells and see the number of origins and destinations, which is the H3 count, and we can see whether that cell whether that cell is in an accident hotspot or not. You can also edit these values in here, so they don't have to keep that sort of that ugly variable underscore setup. But that's not the only way you can do this, because that's obviously like, if you're the end user, great, you can go on and click every single one of these and try and find out where the hotspots are, or we can use widgets to help them. So these are basically graphic elements that you can, kind of like dashboard elements, that you can add to your data visualization that are dynamic, so they change as you move around the map. You can also use them to filter your data, and they're just really helpful for helping your user sort of explore the data and find the data that's relevant to them. So I've just added the total number of trips that we can see within our viewport, but I'm also going to go ahead and add a pie widget. We'll just rename this. I'd normally give these better names, but I'm trying to do this quickly. So we give we can add a pie widget, and we can say, let's look at the total trips, which are in a hotspot or not in a hotspot, which would be like so. And you can see that's been generated here. So I can just click on, for example, here. In fact, we can preview this as the end user. Click on this, and that will filter all of our trips that are just happening in a hotspot. And you can see that's 20,284 trips. So that's a really sort of quick way for your user to sort of basically get to the insights that they want. They can say, well, actually, let's just zoom out to the whole extent of our data. They can say, well, in the whole extent of our data, we've got about 11% of our trips are happening in an accident hotspot. So that's probably not a big enough number to want to implement risk-based pricing across the whole area. The other thing, I'm just going to switch back to edit mode. The other thing I just want to quickly show you before we wrap this up is how to add parameters to this. So I've mentioned these a few times. They are one of my favorite things about creating maps with CARTO. Let's just get rid of these. And what they basically are, I'll just open the parameters window so you can see. You can see what they look like here. They're basically snippets of SQL code that are enclosed in little curly brackets, and they're basically used as placeholders. So you can set up your map so your end user can select from a list of values, and those values can then be basically added into your SQL code so your user can define elements of your SQL query. It's quite confusing to explain, but it's really simple in practice. I'll show you. So first of all, we go ahead and create a SQL parameter. So I'm going to choose text, and then I'm going to say, I'm going to define this by part of day, because what we're going to do is allow our end user here to filter which data is aggregated based on the part of the day. So let's head back to, I've got so many tabs now, this one. And we just need to add in the values they can choose from. So we'll say they can choose from morning, afternoon, evening, and night. And I'm just going to copy this so I can add this to code and hit create parameter. And can you see in the same space where we have our widgets panel, we also have this parameter panel loaded, sorry. So let's go into the SQL code, and I'm just going to add in that parameter here. So back in my original query, we're going to go where part of day, oh, typos, in parameter. So this is basically going to say only include the cells, the records in the aggregation where the part of day is what the user has selected. So you can see that we now have these to choose from. Oh, in fact, we are missing one key option, which is night. So here at the moment, we're looking at this visualization for the whole time period. But if I go into here and I change these, what this will do, you can see the data source is being reloaded and the data is being changed to only reflect that time period. If we zoom in more, we'll be able to see this a bit more easily. Turn up the aggregation as well. So this is now we're looking at the data at its most detailed level, and you can see we can really pick out those street and junction level trends. So here we're looking at just the nighttime data. If I check all values, the data will reload. And any second now, you'll see it's reloading here. So now we're looking at data for the whole time period. So hopefully you've seen a few ways that you can add those kind of the widget and parameter interactions to your map to help you really empower your end users to find the sort of the stories that are relevant to them and the insights that are relevant to them. Just before I tie these things up, I just want to head back to you and show you where I got to with this earlier, because obviously I only had about 15 minutes to pull that visualization together there. That's the map I just showed you. That's not the one I'm after. This one, I believe. I just wanted to show you if I had maybe another 20 minutes or so to go through this with you, I might end up building something that looks a little bit more like this. Let's just go to full screen so you can see this a bit better. So some of the things that are different in this map, I'm just going to come out of 3D for a second. I always love to show maps in 3D, but it's not always the best, most visual way of showing things. So what we're looking at here that's slightly different and an evolution from what I just showed you, you can see we have our total pickups and drop-offs as we did before. We have our accident hotspot filter as we did before. But we've also added a total pickup and drop-offs by neighborhood filter here. So we can see where we have most of our trips starting and ending. So we can see that's Midtown, Midtown South down here. And again, this kind of contextual information is really helpful for helping your end users to find the data that's interesting to them, but also to validate your analysis, because they can find the data and the areas they're familiar with and say, well, that looks about right for there, so I can trust that it's right for everywhere else as well. We've also added in some additional parameters. So you can see, as before, we have part of day, as I showed you earlier, but I've also added in days of week. You can also add in things like dates and numbers, and they don't just have to be filters. You can use them to sort of allow your end user to say what drive time they want to see on a map or the size of a buffer or anything like that. And then the final thing we've added in as well is, as I zoom in here, you can see, let's just filter some of this out. As I zoom in here, you can see, so these orange dots are basically collisions. So another really great way of working with massive data when you're creating a map like this is zoom-based rendering. So making sure that data that's maybe larger, noisier, more overwhelming is only rendered when you zoom in really, really close, so it doesn't overwhelm the overall story of the map. And that sort of goes back to my original point about when you're designing a visualization like this, always be thinking about the stages that the user's going through when they open a map. When they open the map and they start to orientate themselves and they're feeling a bit lost and like, what is it? What on earth am I looking at? Then they start to explore. They start to explore maybe the widgets you've added, the parameters. They start finding their feet. Then they start to get to the like, right, I know what I'm looking at. What's the answer? How can I actually solve this problem? And in the case of this map, that might be, right, I'm going to filter to my hotspots and then start to explore those. And then they're probably thinking, oh, I just want to validate that that's correct. So they zoom in and they see all of these accidents appear, and then they can see, oh, actually, that does look like a hotspot because look at all of these accidents. And they can say, oh, well, lots of this is happening in Turtle Bay, East Midtown? Question mark. And maybe they live in Turtle Bay, Midtown. So they say, oh, I can be sure that that's correct because I know I get a taxi to work all the time. And then they can say, well, I believe these results then, so I can make my decision. So that is just a real whistle-stop tour of the sort of my 5 tips for data visualization and how you can sort of put those into practice in quite a fast example. I don't think I don't think I appreciate how long that might take to explain. But just as a final anecdote, I accidentally, about an hour before this webinar, deleted that entire map and couldn't get it back. So I had to build that up completely from scratch an hour before this webinar. So if you're looking at something like that and thinking that must take ages and ages to build, it actually it doesn't take that much to get to sort of that level, particularly not to be too biased, but CARTO really does make it easy to get to that sort of level of visualization super quickly. I appreciate we're nearly at time, but let me just have a quick look and see if there's any questions to grab. I see a couple from, let's see if there's any. The last question I saw was, what does enriched data mean? Yeah, sorry, I kind of breezed past that. I appreciate it's kind of terminology that not everyone uses. When I say enriched data, I kind of mean maybe like a spatial join might be how you'd refer to it. So basically when you have data that's one geography, so maybe it's like mobile phone pings, it's just pings on a map, and you have data that's another geography, maybe that's a grid like I was just showing you. It would be taking data from that one geography and enriching that other geography with it, if that makes sense. Uh, will version history be on the roadmap? I'm afraid I don't know the answer to that one, but I'm sure we can find that one out for you. Apologies. And yes, we will be providing a link to the recording. So I believe you'll be getting an email probably tomorrow that will have a link to the recording, it'll have a link to the slides, and a link to both the maps for you to explore. Oh, and then finally, I was a bit lost on that aggregation of counts on the H3, which is also an aggregation. So what I was essentially doing there was, I won't share my screen again because I don't think I'll have time to get in and out of it. But basically, when I converted the original data from points to a H3, that was just basically assigning a H3 code to every single point. H3s as a grid cells are, their location is set. So it might be that more than one location falls within the same area of that H3 cell. So when you go to aggregate, when you go to say group your data by the H3 code, you can basically work out how many points have fallen within that H3 cell. And you can use that to basically turn it into an aggregated frequency grid. I hope that helps. If you want to learn any more about any of this sort of thing, you're welcome to message me on LinkedIn. You can find me, Helen McKenzie. But we also have the CARTO Academy, which has loads of resources like this to help you with your learning. So please do take a look there, but do feel free to reach out to me with questions as well. And thank you so much for coming. Thank you, Jocelyn, so much for doing a fantastic job moderating and organizing as well. And I hope to hear from some of you at some point soon. Thank you all. Bye.